Welcome to this study guide for Cambridge IGCSE ICT, Paper 0417. In this first chapter, we'll be exploring the fundamental types and components of computer systems. This guide is designed to cover all the essential theory for Grade 9, including hardware, software, memory, and emerging technologies, and will help you prepare for your exams with past paper practice. So, what will you learn in this chapter? We'll start by looking at hardware and software and how they work together. We'll then cover the difference between analog and digital data, before moving on to key components like the CPU and internal memory, including RAM and ROM. We'll also discuss input, output, and storage devices, operating systems, different types of computers, and finally some exciting emerging technologies like AI and virtual reality. All these topics are directly relevant to your theory exams. Let's begin with our first section, focusing on the basics, hardware and software. We'll look at the distinction between the physical machine itself and the instructions that are needed to make it perform useful tasks. So, what exactly is hardware? In simple terms, hardware refers to all the physical, touchable components that make up a computer system. This includes external hardware that you can see and connect, like keyboards and mice, which are known as input devices, and monitors or printers, which are output devices. It also includes internal hardware fitted inside the computer's case, such as the motherboard and CPU, which we'll be covering next. Now let's take a look at an overview of the key internal hardware components. The motherboard acts as a central hub, connecting everything. The CPU, or processor, is the brain that executes instructions. We have two types of memory: RAM, which is volatile storage for data currently in use, and ROM, which is non-volatile and stores permanent data like boot instructions. The graphics and sound cards handle visual and audio output, while the network interface card connects the computer to a network. Finally, the hard disk or solid-state drive provides the main internal storage for your files and software. Let's look at some of these components in more detail. The motherboard is a printed circuit board that acts as the hub connecting the processor to all other hardware. On the other side, we have the CPU and RAM. The CPU is what executes program instructions, and it contains an ALU for calculations and a control unit for managing instructions. RAM is the temporary or volatile memory that holds the data, files, and parts of the operating system that are currently in use. Next up are ROM and the graphics and sound cards. Read-only memory, or ROM, stores essential information like configuration data that needs to be permanent. It's non-volatile, meaning it retains its contents even when the power is off, and its data cannot be altered. Graphics and sound cards are specialized hardware for processing and sending visual and audio data to your display and speakers. Both of these cards connect directly to the motherboard. Finally, let's discuss the network interface card, or NIC, and internal storage. The NIC is what allows a computer to connect to a network, like the internet, either through a wired or wireless connection. Each NIC has a unique, hard-coded MAC address. For storage, computers use either a traditional hard disk drive, HDD, or a newer, faster solid-state drive, SSD. Both are used to store system software, applications, and all your personal files. Having covered hardware, let's now turn our attention to software. Software is the general term for the programs and instructions that control a computer system and process data. We can split software into two main types: application software, which helps a user complete a specific task like writing a letter, and system software, like the operating system, which provides the platform for all other software to run. A good analogy is that hardware is like the pages and ink of a book, while software is the words. Without it, the hardware is useless. Let's look at some common types of application software. These are the programs you use every day. Word processing software is used to create and edit text documents. Spreadsheets help organize numeric data and perform calculations. Databases are for organizing data in tables. We also have specialized software for control and measurement, computer-aided design for 2D and 3D drawings, and tools for editing audio and video. And of course, there are countless apps and applets for tasks ranging from banking to entertainment. Now for system software. This is the software that manages the computer itself. A compiler translates high-level programming code into machine code that the computer can understand. A linker combines different program files into a single runnable program. A device driver allows hardware to communicate with the operating system. The operating system itself is a major piece of system software that manages everything from input, output, to security. Lastly, utilities are programs that perform maintenance tasks, like antivirus scans or disk defragmentation. Let's discuss the two fundamental types of data: analog and digital. Digital data is what computers process. It's binary, using only zeros and ones to represent discrete values. Analog data, on the other hand, is real-world physical data, like sound or temperature, that changes smoothly and continuously. To process this real-world data, computers use an analog-to-digital converter, or ADC. To control an analog device like a motor, they use a digital-to-analog converter, or DAC. Here's a past exam question to test your knowledge of these key terms. This is a matching-style question, where you need to connect the correct term to its description. For example, a physical component that allows data to be entered is an input device. A small application, usually embedded in an HTML page, is an applet. A revision tip here is to learn the precise definitions of these terms, as matching questions often reward exact recognition. We're now moving into section 1.2, where we'll focus on the main components of computer systems. This section will tie everything together, explaining how input, output, storage, the CPU, and memory all fit together to form a functioning computer. Let's recap the main device categories. Input devices, like a keyboard, mouse, or scanner, are used to get data into the computer. Output devices, such as a monitor, printer, or speakers, are used to present the results of processing to the user. And secondary storage devices, like a hard disk drive or a pen drive, are used for long-term data storage. A typical computer system is made up of all this hardware working together, with the internal components like the CPU and RAM. Let's delve deeper into the Central Processing Unit, or CPU. The CPU is the part of the computer that interprets and executes commands from both hardware and software. Modern CPUs are microprocessors, which are single integrated circuits. The CPU has several key parts: the control unit, which manages input and output devices and executes instructions; the arithmetic and logic unit, or ALU, which performs calculations and makes logical decisions; and registers, which are small, extremely fast memory locations inside the CPU used to hold data during processing. Now let's compare the two types of internal memory, RAM and ROM. The key difference is that RAM is temporary, volatile memory, while ROM is permanent, non-volatile memory. This means RAM loses its data when the power is off, whereas ROM keeps it. RAM can be written to and read from, but ROM is read-only. RAM stores data and programs currently in use, while ROM stores essential startup instructions like the BIOS. Finally, you can usually increase the amount of RAM to improve performance, but ROM is a fixed size. The boot process relies on two key components: BIOS and CMOS. The BIOS, or Basic Input-Output System, is code stored in ROM that tells the computer what to do when it first starts up. When you turn on your computer, the BIOS runs a hardware check and then loads the operating system into RAM. Related to this is the CMOS, a small battery-powered chip that stores system configuration details like the date and time, ensuring they are not lost when the computer is turned off. Let's compare input and output devices. Input devices allow a user to enter data directly into a computer. They can send data, but they can't receive it. They are generally under the control of the user. In contrast, output devices take data from a computer and present it in a human-readable form. They receive data but don't send it, and are controlled by the computer. It's worth noting that some devices, like a touchscreen, can function as both input and output. Since RAM and ROM can't permanently store large amounts of data, computers need backing storage, also known as secondary storage. The main purpose of backing storage, like a hard drive or SSD, is to hold applications, the operating system, and user files permanently. This storage must be non-volatile, so data remains even when the power is off. Unlike RAM, the CPU cannot read from backing storage directly. Data must first be moved into RAM. Storage can be fixed inside the computer or removable, like an external hard drive. Here's a direct comparison between internal memory, like RAM and ROM, and backing storage. Internal memory is volatile, has a much smaller capacity, offers extremely fast data access, but is more expensive per byte. It's fixed inside the computer and can be read directly by the CPU. Backing storage, on the other hand, holds data permanently, has a considerably larger capacity, is much slower, but is cheaper per byte. It can be fixed or removable, and its data must be moved to RAM before the CPU can use it. Let's try another exam-style question, this time focusing on RAM and ROM. This is a tick-box-style question. You would be given a series of statements and need to identify whether each refers to RAM or ROM. For example, data on a chip is stored permanently, refers to ROM. It is a form of volatile memory, refers to RAM. A good revision tip is to build a mental checklist of keywords for each. RAM is temporary and volatile, while ROM is permanent, non-volatile, and holds the BIOS. Now we'll move on to section 1.3, where we'll discuss operating systems. The operating system is the essential software that manages all the computer's hardware and software resources and provides the interface for the user to interact with the machine. So what is the role of an operating system? It's the special software that enables the computer system to function and allows users to communicate with it. Its key tasks are extensive. It controls all input, output, and storage devices, supervises the loading and running of application programs, deals with any errors that occur, maintains the security of the entire system through things like user accounts and passwords, and provides the user interface. Users interact with the operating system through a user interface, and there are several types. The command line interface, or CLI, requires the user to type text commands. The graphical user interface, or GUI, is what most people are familiar with, using icons, windows, and a pointing device. More modern interfaces include dialogue-based systems like Alexa or Siri, where users give spoken commands, and gesture-based interfaces that detect hand or head movements. Let's look at the command line interface in more detail. With a CLI, the user types instructions to perform tasks like opening software or files. It's typically used by programmers and technicians. The main advantages are direct communication with the computer and the flexibility to go beyond preset options and alter system settings. However, the major disadvantage is that the user must learn many commands and type them exactly, which can be slow and prone to errors. Now for the graphical user interface, or GUI. Here the user interacts with the computer using pictures or icons instead of typed commands. The classic PC GUI is often called a WIMP interface for Windows, icons, menu, and pointing device. Its main advantages are that it's user-friendly and requires no commands to be learned. However, it uses considerably more memory than a CLI, and the user is limited to the options and icons provided on the screen. This table provides a summary comparing the CLI and GUI. For method of control, CLI uses typed commands while GUI uses icons and a pointing device. In terms of learning, the CLI has a steep learning curve, whereas the GUI is intuitive and easy. The CLI offers more flexibility, while the GUI is limited to its preset options. The CLI has low resource use, but the GUI's is considerably higher. Finally, the typical user for a CLI is a programmer or technician, compared to a general end user for a GUI. Here is a past paper question on this topic. It asks you to identify whether features belong to a CLI or GUI, and then to compare and contrast the two. For example, instructions have to be typed is a feature of the CLI, while applications are represented by icons belongs to the GUI. A key tip for compare and contrast questions is to give matched points, directly comparing one feature of the CLI with the equivalent feature of the GUI. Let's briefly look at some newer interfaces. Dialogue-based interfaces use the human voice for commands, making them hands-free and useful for people with disabilities. Examples include Amazon Alexa and Apple's Siri. However, they can still be unreliable, especially with background noise. Gesture-based interfaces rely on body movement, such as rotating a finger to change a car radio's volume. They feel very natural but typically only work over short distances. In section 1.4, we're going to look at different types of computer. This will include common devices like desktops, laptops, smartphones, tablets, and phablets, exploring their features, advantages, and disadvantages. First up are desktop computers. A desktop is a general-purpose computer made up of a separate monitor, keyboard, mouse, and processor unit. Compared to laptops, they have several advantages. Their parts are standardized and cheaper, they are easier to upgrade, and they often offer better specifications for the price. The main disadvantages are that they aren't portable, and the wiring can clutter a desk. They are commonly used for office work, education, and gaming. Next are laptop computers, also known as notebooks. A laptop combines the monitor, keyboard, pointing device, and processor into a single portable unit. Key features include being lightweight, with low power consumption and a long battery life. Their main advantage over desktops is their portability. However, they are more easily stolen, have limited battery life, and can be harder to upgrade. They are also used for specialized tasks like control and monitoring in the field. Now let's talk about smartphones. A smartphone is essentially a mobile phone with an operating system that can run applications, or apps. Typical features include high-definition displays, front and back cameras, Bluetooth, and various sensors. Their advantages are their small size, portability, and internet connectivity on the move. The disadvantages include a small screen, quickly draining batteries, and smaller storage capacity compared to laptops. Finally, we have tablets and phablets. A tablet is a touchscreen mobile computer with a virtual keyboard. They are fast to switch on, fully portable, and have a long battery life. However, they can be more expensive than laptops, have limited storage, and typing on a touchscreen can be slow. A phablet is a hybrid device that sits between a smartphone and a tablet in size, combining the features of both. This table compares the typical screen sizes of these mobile devices. A smartphone generally has a screen up to about 5.1 inches. A phablet bridges the gap, with a screen size between 5.1 and 7 inches. Anything over 7 inches is typically classified as a tablet. Despite their size differences, all three types of devices share many common uses, such as entertainment, gaming, internet access, and navigation. Here is an exam question focusing on the types of computers we've just discussed. You are given a description and must write down the computer type that best fits. For instance, a computer that is difficult to move and has a separate monitor is a desktop computer. A portable computer with a physical keyboard is a laptop. The revision tip here is to read the description carefully for the one key distinguishing feature that points to the correct answer. We now arrive at our final section, 1.5, where we'll explore emerging technologies. Specifically, we will look at the concepts of artificial intelligence and extended reality, which includes both virtual and augmented reality. Let's start with artificial intelligence, or AI. AI is defined as a machine or application that can carry out a task requiring some degree of intelligence. This includes tasks like understanding language, recognizing faces, or predicting outcomes like the weather. AI is now found in many real-world applications, from autonomous vehicles and robotic prosthetics to robots used for bomb disposal or entering disaster zones. Artificial intelligence has both positive and negative impacts on society. On the positive side, it can improve safety by performing dangerous tasks, lead to higher quality products, create new technical jobs, and produce better outcomes in fields like medicine and transport. However, the negative impacts include potential job losses in many sectors, a growing dependency on technology, the loss of traditional human skills, and significant ethical and safety concerns over decision-making by machines. Now let's look at extended reality, or XR. This is a catch-all term for immersive technologies that combine the real and virtual worlds. The two main types are augmented reality, AR, which overlays digital content onto the real world, and virtual reality, VR, which fully immerses a user in a simulated digital world, blocking out the real one. There is also mixed reality, which is a further blend of AR and VR. Let's break down augmented reality. Its key features are that it blends the digital and physical worlds by overlaying virtual objects onto real-world views, often seen through goggles or a smartphone screen. A great example is the game Pokémon Go. The user is never isolated from their real environment. In the future, AR is expected to have a significant impact in areas like safety and rescue, entertainment, shopping, and healthcare. Virtual reality, on the other hand, takes the user completely out of the real world and into a simulated one. The user is fully immersed and requires a VR headset to experience the 360-degree view, which effectively fools the brain into believing the virtual environment is real. VR has huge potential for future impact in areas like military and healthcare training, education for exploring historical sites, engineering for visualizing new designs, and entertainment. Here is a final exam question, this time on AR and VR. This is an extended response question asking you to describe what is meant by augmented and virtual reality and how they could affect society. You would need to define AR as overlaying digital images on the real world, and VR as fully immersing a user in a simulated environment. For the impact part, you could discuss ideas like safer training, improved retail experiences, or new forms of entertainment. A good tip is to always give a specific context when describing impact. To summarize, here is a checklist of the key terms we've covered in Chapter 1. We've looked at hardware and software concepts, key components like the CPU and memory, operating systems and user interfaces, different computer types from desktops to smartphones, and finally, emerging technologies like AI and VR. Use this as a checklist to ensure you have a solid understanding of all these core topics. Finally, let's go over some important exam skills for Paper 1 and Paper 2. For name or identify questions, a word or short phrase is enough. Describe questions need a clear, developed point. Explain questions require a reason or a because. For compare and contrast questions, always write matched pairs of points. For tick box questions, learn definitions precisely, and always use correct terminology. Examiners are looking for specific terms, not everyday language.